a battery equivalent circuit. This is a battery equivalent circuit, and in my next video I will illustrate how you can now make a battery pack from a single battery. Okay, we need now to model this RC circuit, that is a battery equivalent circuit, in MATLAB. Let's now start. You need now to open Simulink from your MATLAB. If you go to MATLAB here, the Simulink, you just click it once, it will open. Okay. Then we need, in a Simulink environment, we have various libraries to be used. As you can see, there are very many depending on application. Today our main focus will be Simscape. We're going to use Simscape here. It is a very important, very powerful library that we can model a fully functional electrical vehicle and have some various simulations to get various parameters. But with time, I will go through some of them, like a 3D animation, powertrain block set. But now, as we begin, we are going to use Simscape. And for us now to model the battery equivalent circuit, we need to use foundation and we need to use electrical library. First thing we need a resistor and a capacitor. You go to foundation, library, electrical. We have three types of electrical elements: sensor and sources. We need elements where we can get resistor. There are two ways of inserting the resistor into the model. You can left click, drag it, or you can right click, add block to the model, or in the model you can right click and drag. Those are three ways you can add. You can copy. That's one way you can copy a resistor. Still, you can right click and you can copy and paste. Okay, we need only two resistors. Let me delete. We press space bar to zoom. Then we need a capacitor. There's a capacitor. Okay. We also need electrical reference. As you're going to see, well, we have various domains in Simulink. We have electrical domain. As you can see here, we have hydraulic domain, isothermal. These are domains. Each domain needs a reference point. And electrical, we use electrical reference. If you go to hydraulic ones and the elements, you are going to have hydraulic reference. Okay. When we start modeling the cooling system of electric vehicle, I'm going to go deeper to the other domains. Therefore, for now, we need to use electrical reference here. Lastly, we need a source, that is a DC voltage source. Still, you can have DC current source, but now we're going to use a DC voltage source. Okay, now you can maximize and you press escape. You press escape bar. Then you have to connect all these blocks, all of them, as per circuit. Okay. I'm connecting them as per circuit. Yeah. Then you can press space to zoom. Okay, we have connected them as per circuit. Then we need now to define the values of resistor, capacitor, and voltage source. You double click on the voltage. We have parameter here. and you put the value. My value will be 110. I'm going to use 10 for now. Then you can have the units. I'm going to use a V. Okay. If I need this 10 to be displayed, right click on the source. You go to properties. You go to block annotation. These are the properties that are associated with the block that can be displayed. For now, I just need to display the value of voltage, that is 10 V naught, and we need V naught units. Therefore, it will display 10 V because V naught unit is a V. You can still customize this. I want them to be displayed in this format like that. Apply 10. You can see now it's displaying a 10 here. I want this to be on this side. On this side, no, doesn't matter. The same case applies here. Resistor. I can first for double click and select the value 0.01 ohms. Variables are used to set the initial conditions. As you progress, some blocks will have the initial condition, but for now we leave them as none. Okay, variable means it is something that is varying with time, but now there's no initial condition. This doesn't change. It is 0.01. Okay, 10. The same case applies here. 0.005 ohms. Variables doesn't apply. If you're using a kilo ohm, mega ohm, can still use the units that, yeah, that is maybe available. Capacitance, we need 5,000 F. That's okay. I want these values to be displayed. You go to properties, block annotation. We need value of R unit. Yeah, you can customize. I want them to be displayed in a bracket like that. The same case applies here. Properties, block R unit. Customize this. It is good to make your blocks representable so that someone else can understand your block easily. And still, once you make your block representable, you can be able to troubleshoot easily. You're going to see the more you progress, the block will become very complex, and you're going to see the importance of this. Okay, we have modeled our battery equivalence RC circuit, but we have used 10 for ease of display. Then, as I said, we have various types of domains. This one is electrical domain that has blue lines. For us now to get the current here, we need a sensor. At this sensor, we can only read the sensor in another domain that is called Simulink domain, a Simulink signal. This one is a physical signal because you are using the actual blocks, the actual building blocks. Therefore, we need a sensor to sense the current. Then we need a way. We need then we need a converter block that will enable us to convert our value of current from electrical domain to another domain. Okay, let's first use a current sensor here. We need a current sensor here. You go back to library, you go to sensor, and I need a current sensor. In fact, I want to use both. Okay, let me use both. We're going to use V to read 10 and this A to read the current in the circuit. Therefore, you delete this, you put your current. Current is usually measured through the circuit, but voltage is across the circuit. I want to know the voltage across here. Okay, across here. As I said, this one is those are physical signals. physical signals that need to be converted from electrical domain to another domain. We need to display the value of current here and the value of voltage into a scope. Therefore, if you know the block by the name, you can type. If you start typing the block, this is scope. It, yeah, you can be able to select, or you can go to library. You can go to Simulink. We need a sync, and you can use a scope here and a display. We're going okay. Therefore, if you try to read this value directly, it is impossible to connect these two. As you can see, this one is black. Black symbolizes that scope is found in Simulink domain, but this blue is in electrical domain. Okay, therefore we need a converter. You go back to library, you go to Simscape utilities here. You can now select PS physical signal to Simulink converter. Okay, therefore I need to convert this here. Let me zoom out a little bit. I want to put my scope here. Then I can easily connect to scope because now the signal is readable. Just making my, yeah, okay. That's better. Then this value, this one will going to give us a value of V. Let me use this. Let's put this here so that, yeah, so that I can be able to type voltage here. V naught. V naught. That is value of 10. Then this one, another one. We need, you can right click, drag to copy like that, and you connect this one to scope like that. This one is I current. Double click the scope. We need to have select the gear icon. Layout, I need two axes, one for V naught and one for current. You can see two axes by selecting the gear node here, the gear. Then the number of input ports, I need two layouts. Sometimes you can have even 10, 6, depending on what you need to display. Okay. Then we can select the units here. You can set the unit of what you need here. But now I need it for one means we are not using the units. It is going to copy what is available. I can have inherit to use the units available here. One and inherit are usually function similar. Depending on what you're using, sometimes you might need your unit in pascals and maybe the pressure available is in bar. It depends on what you're using. But these units should not contradict. If I select another unit here, for example, newtons, it will bring an error because units should not contradict. But for now, leave them as default. Okay. Now we have used this PS as a interface between the electrical domain to the Simulink blocks. These are blocks that are in Simulink. As you can see, this one was in Simulink. Therefore, in the Simulink, all these, we have so many blocks that are available in MATLAB. The first block is usually called Simulink, but that's the reason why we usually call this Simulink. But it has many independent blocks. Now, for you to use one block to the next, you need a converter. I'm converting a electrical signal from Simscape library to Simulink library using a block converter. Then lastly, we need a solver. Okay, solver, we go to library. Solver is where you define how your model will be solved, because MATLAB is a simulation and it needs to solve. If you do various analysis, you always use. Therefore, you go to utilities and you select your solver here. You can always attach your solver anywhere, okay? Depending on how I can also attach it here. The control R to rotate. You can also attach it here, okay? Like that. Now, in the solver, we need to set some settings that will enable us to be able to simulate this. For you now to change the settings in the solver, you press Ctrl E, or you go to modeling and you select this gear icon, model settings. Okay, now we are in a solver environment. We usually have two types of solver here. We have a variable step, that's fixed step. You can do some research on these two, but for now we are going to use a variable step. For the solver, we have because we have very many blocks. We have Simulink, we have block set, we have Simscape. Depending on the library you're using, you have to select certain solver. When you're using a variable step in Simscape, we recommend ODE 15S and ODE 23T whenever you're using a Simscape variable solver. When you use a fixed step, we recommend ODE 14X for extrapolation. But for now, we are going to use a variable step, which is ODE 15S. And this is the time taken to simulate. We want to run our model for 100 seconds. You apply. Okay. Then for the, if you go to simulation, still I can use this time here. I can note this. As we advance, we are going to use many, we're going to have very many models at the same time. For example, we have electrical domain, mechanical domain. For each domain will have its own solver. Okay? And the solver is used to define or to define how your model will be solved. And then repeat again. For the variable step, always use OD15S, OD. For the fixed, use OD15X. One for X, not for T. Okay? Then you can now save your model and run your model. Double click on the scope to get the V naught. It is 10. The 10 we is the 10, the one we inputted in parameters. You can see it is 10. But you see the current drops. For us to get the exact value of this current, because right now it can be difficult to know the final value, I'm going to use a display. Let me use a display so that we can be able to display the current in our model. Yeah. Okay. Zoom here a little bit. Yeah. Like that. Let's now run again. Yeah, this makes sense because the current is approximately, 10. You divide by this plus this, should be around that. Yeah, that makes sense. Thank you for watching. Stay tuned for my that video whereby we are going now to combine this single battery and maybe have about 20 batteries and make a battery pack. Then that battery pack We are going to use it to model our because we are going to vary the battery pack value depending on the type of motor we are going to use. Thank you. See you in my next video. Please subscribe.